Hi, this is McClellan, here to go over IM2 Chapter 9.1 Checkpoint with you, and it's the practice. Here we go. First problem says, given the function f of x equals x minus 3 squared minus 1, determine the vertex, a value, and step pattern. So our vertex comes from our graphing form equation. We have f of x equals a x minus h squared plus k, and the vertex is at h comma k, which for us is 3 comma negative 1. Our a value is 1, since the number in front of x minus 3 squared is omitted. It's just 1, so a is equal to 1. So my step pattern is 1 times 1, 3, 5, which is just 1, 3, 5. So I start with my vertex, I plot 3 comma negative 1, and I apply my step pattern by going over 1, up 1, that's the first step, oops, over 1, up 3, and that's all that's going to fit, because I can't go up 5 more. Okay, I turn these into points. I mirror the points across the vertex, and I connect with a smooth curve. Oops. Looks like I went a little below my vertex point there. That's okay, I'll just make my line thicker. Looks great. Okay. Next problem. Given the function f of x equals negative 2, x minus 3 squared plus 5 will determine a vertex, a value, x-intercepts, and step pattern. So I have a little bit more work to do this time because I want the x-intercepts. Starting with the vertex, I'm at hk, so that's 3 comma 5. My a value is negative 2, so my step pattern will be negative 2 times 1, 3, 5, which gets me negative 2, negative 6, negative 10. Okay, I'm going to start with my graph. I think that's easier than finding x-intercepts. So let's see. My vertex is over 3, up 5. I go over 1, down 2. I go over 1, down 6. And then I won't have room to go over 1, down 10. So I'll just mirror that. Okay, smooth curve. Smooth curve. Okay, so I can't tell what my x-intercepts are just from looking at the graph, so I'm going to have to solve. Oof. Okay. So to find my x-intercepts, I set y equal to 0. So this is going to be 0 equals negative 2 times x minus 3 squared plus 5. I'll subtract 5 from both sides. I get negative 5 equals negative 2 times x minus 3 squared. I divide both sides by negative 2. I get 2.5 equals x minus 3 squared. I take the square root of both sides. I get x minus 3 equals plus or minus the square root of 2.5. So x is equal to 3 plus the square root of 2.5 and 3 minus the square root of 2.5, which gives me x-intercepts of those values, 0, comma, 3 plus root 2.5 and 0, comma, 3 minus root 2.5. Those are my x-intercepts. Okay, next problem. Write the equation of the function f of x that is a horizontal translation 4 units to the left and a vertical translation 2 units up from the function y equals the absolute value of x. So my graphing form for this function is y equals a, absolute value x minus h plus k. It looks like I'm doing 4 units to the left, so this will look like plus 4, because remember the h changes sign. And it will look like 2 units up, so k is going to be plus 2. I don't have any information about a except that I'm starting with y as the absolute value of x, so a must be 1. So f of x is going to equal the absolute value of x plus 4 and then plus 2. Let's graph that. So, I start with my vertex, which is at -4, 2. -4 up 2. My a value is 1, so my slope is 1. So I'm going to go over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1. This is an absolute value function, so the slope is constant. And I'll mirror that on the opposite side of my vertex. Okay. Next problem. Number 4. Convert the quadratic function f of x equals x squared minus 6x plus 5 from standard form to vertex form by completing the square. I'm going to take this by completing the square thing out, and I'll show you 2 different ways to do this. Okay, method 1, completing the square. In order to do this, I'm going to make a box. X squared goes here. I take my b term, -6, and I divide that by 2, so I have -3x and -3x, and then I find what it takes to complete that box, which is plus 9. So I have x squared minus 6x plus 9, but then I also have to subtract that 9 so that I don't change the value of my expression, plus 5 is what f of x equals. See, it's just like adding a 0 inside there. And that can turn into x minus 3 squared, x minus 3 coming from the outside of my box, and that's why it's squared, which came from this part of my equation, and then minus 4, which comes from this part. I should have said for my expression, by the way. Okay, so graphing form is going to be f of x is equal to x minus 3 squared minus 4. Another way to do this is to find the vertex. And I can find the vertex using the fact that the vertex is at x, the x component of the vertex, and the y component of the vertex. Now the x component of the vertex is equal to -b over 2a. And we have this in graphing form, ax squared plus bx plus c. Here, -b would be negative of -6, and I divide that by 2a, where a is 1. This is 6 divided by 2, which is 3. That is the x component of the vertex. To find the y component of the vertex, I simply plug 3 in for x into my equation. So that gets me 3 squared minus 6 times 3 plus 5. Now, I predict that if you throw that into your calculator, you get minus 4, but let's just confirm it. That's 9 minus 18 plus 5. That's negative 9 plus 5. That is, in fact, negative 4. So the vertex is 3, negative 4, which creates this very equation right here. Both methods work. Now, if A had not been 1, I would have used the exact same process to find my vertex with this method, method 2. And then I would have put my A value right here in front of the x minus 3 squared. Okay, number 4b. Convert the quadratic function g of x equals x minus 3 squared minus 4 from vertex to standard form. All right, this is a little bit more straightforward. I expand x minus 3 so I multiply, here's x squared minus 3x minus 3x plus 9. This part is x squared minus 6x plus 9. And then I use that to finish. So I have x minus 3, sorry, this thing should have said squared. X minus 3 squared minus 4 is equal to x squared minus 6x plus 9 minus 4, because x minus 3 squared we just found is the same as x squared minus 6x plus 9. The product is equal to the sum. And then I just have to rewrite this one more time. This is x squared minus 6x plus 5. The standard form version of g of x is x squared minus 6x plus 5. Now, you might notice that these problems are kind of like the same thing. It won't be like that on the real checkpoint. This was an oversight on my part. You'll have functions that are not equal to one another. Okay. That's everything for the actual checkpoint. I'm going to do a couple further questions for you. Okay, further questions. Instead of saying that a problem moves 3 units left and 2 units up, you can say that the parabola's position is displayed by the vector 3, negative 2. Identify the following displacement vectors. Grizzy starts at 2, 3 at 1 p.m. and is moved to 5, 9 by 6 a.m. the next morning. So my x value is going from 2 to 5. That's a change of 3. My y value is going from 3 to 9. That's a change of 6. My vector, my displacement vector will be 3, 6. Okay, next one. Now keep in mind which comes first. This says at noon Eugene is at 3, 4. 2 hours earlier, Eugene was at 6, 2. So we're going to start with the earlier one. So I'm going with my x from 6 to 3. That's negative 3. And for y, I'm going from 2 to 4. That's positive 2. My vector is negative 3, 2. During a single hour, a small airplane flew 40 miles north and 100 miles west. Well, in order to do this, I have to know that how north, south, east, and west coordinates are. North, south, east, west. So 40 miles north is y, and 100 miles west is y. Sorry, this was y equals 40. 100 miles west is that x is equal to negative 100, because this is in the left-hand direction. So my vector will be negative 100, comma, 40. A bug is initially at negative 3, comma 7. Where's the bug after being displaced by a vector? Negative 7, comma 8. So what's happening to x? Well, it's taking 7 away from it. We're taking 7 away from x. So the new x value will be negative 10. What's happening to y? Well, we're adding 10 to it. So 7 plus... No, sorry, not 10. We're adding 8 to it. So 7 plus 8 brings us to 15. So our new location will be negative 10, comma 15. Given the vector negative 5, comma 12, find the following vectors. We have one vector. Same direction, but twice as long. So this becomes visual. So this vector was at negative 5, comma 12. Erase that, make it lower. Okay. So negative 5, comma 12. And we want to double the length and go in the exact same direction. So I'll do that in another color. I'm going to double that length. What happens when I double the length is that my x value doubles. So my new x will be about up here somewhere. And my y value also doubles. So I'll have to go 12 higher. So my new point should be here. Okay. So my new vector is going to be negative 10, comma 24. And there are a lot of consequences to the fact that you can simply double the components of a vector that you may learn in physics, but you can also learn them in math. It will come up in something called linear algebra, which you will take after calculus. All right. This is the end of IM2 Checkpoint 9.1 practice. Hope you have a great day. Bye.